All right, hello scholars. You'll notice things are a little bit different this time because I am currently recording on my laptop, so the iPad. But that's because I want to hop between some tabs and show you some cool stuff. Excuse me, sorry for the yawn. Okay, so we're just gonna fill these notes out first. So now what we really want to start talking about is why should we use a polynomial curve instead of a line of best fit? Why is that true? How do we know it? Okay. Um, And so first, I'm just going to say, we'll do this in red so you can see it real nice. Sometimes a polynomial curve should be used to model data, model, and make predictions. Okay. So sometimes a polynomial curve should be used to model data and make predictions. Okay. Sometimes it just fits it better. So if you want to see a good example of what that looks like, we can hop on over to these are the graphs that come from this link right here, so you can check those out. But anyway, yeah, if you look at this data right here, you can see that over here on the left hand side, we're trying to make this line fit the data properly. The line of best fit just doesn't really work, right? Because if you get close to this part down here, you miss out all this data up here. And if you get close to all this data up here, then you start missing this data over here. If you look on the right hand side, you'll see that the curve starts to fit this data really, really well. Okay, so if we want to trust the predictions of our model, we definitely want to be using some kind of curve or line that fits the data really well. Okay, so there are situations in which that the polynomial curve is better, but we do have to be really careful with polynomials, as we'll see. Okay, so let's figure out this next thing. So this next note says, as we increase the degree, this is really important, the degree of the polynomial, we are able to model, we're able to model the data points better. So fill that in on your notes. And so I think this is I'm going to use the data from one of your examples. I think it might be from number 7, I believe. Yeah, it's going to be from number 7. So if we take a peek at this is the data for number 7. Okay, I might spoil some stuff for you, but that's okay because we're about to go over the video for number 7 anyway. So if I look at this thing, it looks like I chose some kind of polynomial curve to fit this data. Okay, this is the volume of an audience over time. So basically, this is the time in seconds, and then a comedian is doing like a stand-up routine, and then the audience is quiet here, and then they start laughing a little bit, and then it quiets back down, and then it gets funny, so they start laughing a little bit. So it looks like we have a polynomial curve that fits this really well. I can do some interesting stuff to this. Yeah, here we go. Okay, I can do some interesting stuff to this and change the degree of my polynomial, and you'll see that interesting things start to happen, right? So if I start at just a degree 2 polynomial, it doesn't really fit the data that well. I missed this giant curve up here. I missed these smaller curves right here. So if I increase it to 4, you'll see that I start fitting the data a little bit better and a little bit better each time, right? And this, to me, degree 4 looks pretty good. But you'll see as I keep increasing the degree, an interesting thing happens, right? So now I start to fit it even more perfectly. Like it's almost like eerily close how perfect I'm hitting all of these data points. Okay. And then if I keep going up in my powers, I keep fitting it better and better because as I increase the degree of the polynomial, I can continue to make this polynomial even more and more curvy if I want to. And so by the time I get all the way to polynomial degree 10, I have officially hit all of the data points perfectly. So basically, what's happening here is your computer is when you have a higher degree polynomial, your computer can make that polynomial as curvy as it wants, and so you can make it fit the data perfectly. But when you get so high with the degree, um, it fits it too perfectly. This is called overfitting because if you look and see, we make the ends of this polynomial really really sharp, right? So this all of a sudden is describing a scenario modeled by a polynomial to degree 10. We really have no reason to believe that there's all these tiny twists and turns in between every single part of the comedian stand-up bit. It's almost so accurate, or it fits the data so well that it can't be a perfect story. And then what ends up happening is you'll see that these ends right here shoot up really, really drastically when compared to lower degree polynomial, which means that our yeah, see how these ends just kind of go out at a much slower rate. Like this doesn't shoot up quite as quickly. So that means the predictions that I make will be sort of more stable, whereas the other predictions will shoot up to infinity right away, and so it won't be as good over time. Okay, and so that tells us, however, so let's fill out these last set of notes based off of that information. However, the degree, I should say, wait, yeah, sorry, hold on. It's a mistake on my part. However, increasing the degree of our polynomial curve. So if we increase the degree of that polynomial curve, um, however, increasing the degree of oh, sorry, this is a mistake. However, increasing the degree of our polynomial fits our model. Yeah, we're going to say fits our model and makes our predictions less accurate. Okay, it makes our predictions less accurate. So the higher up, sorry, yeah, that was a typo on my part. Okay, however, increasing the degree of our polynomial fits our model and makes our predictions less accurate. So it fits our data points really, really well, but it makes our predictions less accurate. It almost fits them too perfectly. Okay, so in order to use a polynomial curve as a curve of best fit, we need justification. Okay, so that basically means we need to be able to explain why our polynomial fit actually matches the correct data. Okay, so there's some situations where it is justified to use a polynomial, like in situations with gravity, like the ball falling down. We always have something that goes up and it comes right back down. So a quadratic always makes sense for those. Um, but we need to make sure that we are justifying our curve, and we'll see what that looks like when I go through some of these next few examples. So, thank you.